Okay, I'm reshooting that whole video because that was very babbly, very babbly. So I want to do this real quick. So I don't want to dwell on it too much. Please watch the previous video. There is a sex of the tetrahedron. The tetrahedron, there is an up and a down that the tetrahedron has to make. And I don't want to dwell on it too long. I want you to catch it quick and then move on because it's an important point. But as we can see here, these two shapes are using the plane to define the bottom, and they're using a vector to go up. In this position, they're using the vector and a point to create the plane going up. So if we look at these, we can see these are all the same. But this one is different. This one is different. If you put the planes in, its vector going up is the opposite. This is a male and the others are female. Now, if we go to points and vector instead of planes, we see the same thing. We see the same thing. So the actual shape of the gender of the universe, and the reason we have gender, is because there has to be something pushing up and there has to be something pushing down. That essential relationship is found in the tetrahedral shape and is found in pretty much everything that forms in the universe that has form, because the tetrahedron has to be the basis of that form. Okay, so that's a really basic understanding of the tetrahedral shape. This shape holds the past, the present, and the future. This is the most basic shape. Okay, now this shape cannot observe itself. I did a previous video called number 1, and that's pretty much the best place to really understand. I really cracked down for 10 minutes on it. It's a really easy thing to understand. But basically, when the tetrahedron tries textulating its own shape, it can never do it. It can never make its own shape. You see that? Because it can never observe itself, it is forever in a broken situation before the square exists, before there's another shape size. Now, I want to go into this, and I'm just going to say this real quick. This is something I wasn't going to go into, but I'm going to go into it just real fast. So this is the actual second shape that's created. And do you see this 6-inch distance right here? That's the same as this see that? It's the same distance. Same distance. So this shape is the first. These two shapes are the first shapes of the universe. And every one of these, from getting to this point to this point, is 3. 1, 2, and 3. This point to this point, 1, 2, 3. There is a past, a present, and a future held in each one of these distances. So there's 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There are several ways for this past, present, and future to end up in the same spot. And this is the first singularity. So from this shape, trying to observe itself, it comes into this. And basically, this is the blown up shape. You can see this is the blown up shape. And what happens is that these two shapes try to observe each other. And what happens is a space. Do you see that square that's in the middle there? See the square that's in the middle? I don't know if you can see it. I think it comes in moments. This is the side of the square right here. I'm touching it. Side of the square. This is the 3 sides of the square. Yep. So basically, as they're spinning, some moments they click and they observe each other. When they do, the energy spins around and gets caught. When that energy is caught and observed, it's spun into this shape. Now, this is the electromagnetic shape. Now, I just did the numbers with you guys, and I want to give this to you guys. I want to give this to you so deeply. Let's continue with it. Spun into this shape. It gets spun a little bit faster. This is the shape of solid. and it gets settled on this situation, and these two rock back and forth, and there's a mixing, and I can show you another structure if you wanted to see what space looks like, but we'll do that later. What the heck? Isn't that beautiful? Anyway, space. Okay, going back to this thing, we have the solid, the liquid, and the gas. All Plutonian shapes, all Pluto shapes, all worked out. How the spin map works. There's the spin map right there. There's the spin map. When it's not spinning faster than light, when it's spinning faster than light, the perfect speed of light, it's the octagon. When it needs to spin up some of that energy so it can maintain the square in the center, so it can maintain the square in the center, the two tetrahedrons spinning, it will spin the electric shield up and get rid of some of that extra energy and turn into liquid. And when it's doing that, it forms this 20-sided shape. And then when it heats up with the UV energy, and it wants to get rid of some of that energy, it'll spin up to the gas shape right there. Okay, now there is only one tetrahedron experiencing itself. And that's hard to explain, but the tetrahedron's maintaining its size because there's only one of them. It's only one tetrahedron experiencing itself. And right there you can see it. That's the Star of David so beautifully. The Star of David so beautifully. But if we take this and we make it into a box, we see the box right there. And if we unbox the box, we take the top of the box and we put it to the bottom, open up the box, we get the cross, right? So we have the Star of David and the cross right there. Now, at the beginning of the universe, there's a point where the tetrahedron has taken one spin on one corner and rotated this much away from its original position. So it originally formed this tetrahedral star, and then it took 1/3 of a spin. And it is still there observing all of us making spin moves out. Now, it has 0 spins on all of its corners, and one corner has made one spin. So there is an atom that has that. Now, if we assign a number to all of these corners, 1, 2, 3, 4, 5, 6, 7, 8, there's 8 numbers. And of these 8 numbers, if the tetrahedron is experiencing itself, every position that the tetrahedron could spin into, it moves a distance and spins, moves a distance and spins. It doesn't record the distances, but it records the spins. So it can, so it doesn't hit itself, it doesn't destroy itself. What would be the 9th spin that it records? So let me say it again. If it's here and when it first forms, and then it's like, oh, it formed here as a square, I'm going to rotate every one of these. So I'm not explaining this well. Every one of these corners has 3 digits attached to it for 27 digits. So there's 9 corners, and each one has 3 spins. No spin, high spin, medium spin. Each one of those has 3 corners and then a distance that it travels in that after it spins. What would be the 9th spin? And that would actually be the square. So if we make it into a square and we rotate the square this way, or diagonally, that is the 9th spin. So it can spin and rotate on each one of these corners for 8 spins, but its actual rotation is the 9th spin. And if you give it 9 spins, there's an infinite amount of positioning it can give. mathematically. Thank you.